Yep.
And hello, welcome to in session number 21 it is now.
We're so grown up.
Yeah, totally. Oh, I can have a drink now. Sorry. Yeah, so very nice to have everybody. Today actually with Tommy Etkin, and as advertised, we'll be looking a little bit into RayTK. And who else is with us? Isabel? And
yeah, I'm having a slight problem, which is that I'm getting some I'm hearing everything twice, and I'm not sure where because I have the stream.
No, that's when we're growing up.
What do I turn off? Okay.
So maybe I'll continue that. Who else we have in here is Malcolm and Greg as well. Well, actually, it's probably a lot of asking questions of Tommy in this session.
Yeah.
And learning about the system there.
Yeah, so maybe we can introduce RayTK briefly, and then Tommy can expand largely on it. But basically, it's a free-to-use library that you've been developing for a number of years that people can use to basically construct and render ray marching shaders in TouchDesigner without the use of GLSL. And I really like how you've sort of dubbed it ray marching for the masses, which I think is a good way of putting it. So first of all, thank you for creating this, Tommy. We were remarking yesterday how if you go to Instagram and hashtag RayTK, there's over 1,500 beautiful things that people have created using RayTK. It's quite an addition to the toolkit of TouchDesigner users all over the world. So, what can you tell us about how it came about and your process and all the good stuff?
So I had kind of admired ray marching. That's something that I would never be able to figure out. I kind of would see things on I'd be really impressed and then assume that I would never be able to do that. And then at the end of 2019, I started looking at Patrick Lechner's TD ray marching toolkit. And through that, I kind of figured out that ray marching can, I could understand it in parts, and it's just a lot of small parts that make, I don't know. So eventually I kind of gained some understanding of it and started trying to add things to that toolkit and make a few changes and add different kinds of shapes. And then at some point I realized that if I was going to make this into something that other people could use, I would need to kind of start from the ground up and design it with reusability in mind. And so I started rebuilding it basically from scratch, and that was kind of throughout most of 2020. And then in November of 2020, I did the first public release. And then since then, I've been working on it a lot, and we're now up to the we just did the 27th release. Yeah, and
how much of your time is this taking up, roughly?
Well, until a couple of months ago, I was working a full-time software development job, so it was kind of sitting around that, 15 hours a week or so. Now it's probably closer to 20 to 30. And that's a mixture of kind of using it to create my own scenes, and that's a lot of the stuff that I tend to post on Instagram, the videos that are shown here. And then as I'm doing that, I'm kind of finding things that I wish were there and then adding them and finding, it's a way that I sort of do QA on it while also developing content.
And that's that's the beauty reel that we're looking at right now.
So what's your programming background? Because just looking inside it, it looks like it's very professionally structured and really well designed on the inside.
Oh, thanks. Yeah, so I've been, I was working in the software industry for about 13 years. So I got a computer science degree in 2009, and then I spent about 6 years working at an educational company doing a lot of like online learning, web development, a lot of C# and JavaScript and XQuery and some other and Java, and then I switched over to Google, where I was initially doing stuff related to flight search that was in Lisp, which I didn't know particularly well and wasn't that great at. But eventually, I moved on to a different team where I was doing kind of an API layer on top of my previous project, which is in Go, and then another layer on top of that, which was Java, and then I moved out to LA in like 2015, and then started doing primarily front-end development for like an ad campaign planning tool. And that was a lot of Java and Dart, which is kind of a JavaScript related language. And so I spent 6-ish years doing that kind of development. And for the last 3 of those, I was part of the team that enforced and like educated people about the coding standards within the company.
Wow.
And I guess that then something like this, just because you said enforce coding standards, that helps with actually coming up with the architecture of the whole thing, since you're developing a full development kit with it as well.
Yeah. It's I find a lot of the sort of practices that one uses when developing traditional software, like Orange, really part of the TouchDesigner workflow. And I mean, people like we do, a lot of people use source control, but the concept of like a build process and automated testing is like aren't really there in at least like in the kind of public facing portions of TouchDesigner development. So I put a lot of effort into making a set of development tools that could bring those practices in. So one of the core principles of RayTK was that you can load it into a project, you create a scene, and then you can pull the library out, and your scene is just a self-contained thing that will run. It has no external dependencies. It's like a fully reusable thing. And as part of that, like in order to enable that, the toolkit itself is like a fully self-contained component, so it doesn't have has no dependencies outside of it. But the source for it is like a massive directory of like 3,000 something files, and then there's a build process that kind of detaches references to all those files, does a bunch of cleanup, it strips out some stuff that's kind of not needed for the public, and then packages it up into a nice like self-contained talk that people can use. And then there's, along with that, an automated testing system where each operator has a suite of tests that go with it, and as part, while developing, kind of have the test up in one window and development in the other, make sure that things are still behaving the way they should, and then before doing a release, I'll run through it runs a system that runs through all the different test cases and checks for any shader errors. There are some kind of like subtler bugs, like the shader isn't in an error state, but it's doing something weird, but that's a little bit harder to catch with automated tools. But that's where a lot of the manual QA comes in. So kind of taking this like mentality of working at a software company and trying to like apply it to this kind of development.
Mm-hmm.
Yeah, the thing is, it's pretty cool that it's one tox file. That's it, not even a TOE file, and another tox file full of examples. But I think, Isabel, you wanted to go through some of Tommy's other past?
Yeah, exactly, because you think that RayTK was it, but it's not. You have you have your own company with 2 other people.
Yeah.
And you also we look at virtual sky, and you actually use RayTK on this one. You said for
yes,
volumetric lighting.
Yeah. So this is an installation at the Oklahoma City Convention Center, where there are kind of 2 lobbies in 2 different sections of the building that have these grids of tubes coming down from the ceiling, and LEDs placed along them, and we kind of move like abstract patterns through that space, and it's based on like weather data. So we have, different patterns that'll show up if it's raining or if it's cold, or and that kind of thing. And the logic that goes into figuring out what color each LED should be is basically the same as what's needed in ray marching. So a lot of the components of it was able to reuse. And within RayTK, there's the point map render operator that you give it a bunch of positions, and for each one, it kind of evaluates the scene and figures out, is this part inside a shape or outside a shape? And if so, what color is it? And so we're using that kind of paired with the weather data to create these patterns.
Yeah, like ray marching is really conducive to 3D sculptures like this, points in space where you have to sample them.
Yeah.
Partly because these are solids that you are rendering, not to polygon surfaces, so you don't have to think about inside or outside of polygons or either side. So it's kind of conducive to using ray marching and RayTK for 3D sculptures, I think.
Yeah. It did have some challenges where, like, a lot of the projects that I've done at Studio, or Dolly Studio, traditionally involved an animator, Sebastian Pesera, who does these meticulously rendered ultra high resolution, Cinema 4D renders that take a week, and so we had to kind of, video content doesn't really work in this format, so we had to kind of develop a flow for creating the content for it. So RayTK kind of served as like a core part of that, where it's sort of laying out shapes and then applying transformations to them rather than like sequencing out animation and rendering it as a video.
Yeah, it's gorgeous. And you work completely remotely on this, right?
Yeah, so most of the development of this took place in 2020, so nobody was going anywhere. And then in 2021, did the installation, and I kind of did a lot of remoting into machines and having people standing there with a camera looking at it and kind of testing things one by one. And it went pretty smoothly, especially given like how many people. Yeah,
It's so elegant. It looks completely timeless. Like it could just stay forever.
Yeah, and that's one of the things that like I kind of had to learn when working with Dolly Studio, is that it's designed to run unattended for like many years. So you need to build things in a way that's like very resilient and like fault tolerant. And if it isn't able to retrieve weather data, like if the weather API company shuts down or something, like it needs to be able to handle that situation. And it has to like log when things happen, and report if things are falling apart, and kind of exist as this like very independent entity without anyone sitting in front of it.
Nice. And then the other project you worked on that's also using sort of environmental data is object permanence, again with Dolly Studio. And, go ahead.
This one is in the lobby of the Santa Monica Marriott. So it's a set of these 10 big panel segmented into 10 parts, and it's kind of themed off of like Route 66, which is kind of part of the hotel's sort of theming, and branding is around that. So there's a combination of some of this like very abstract footage, like was shown in that shot there, and that's all by Sebastian Peschiera, who does the like really high resolution renders. And then there's also a set of kind of drone footage of the road itself, and like a lot of scenery and material that was shot by going out onto the road itself with a bunch of cameras and producing this large library of content. The big challenge there, though, was that the content was all shot in 1080. The video content, the like animations we could do those at full resolution, but because we couldn't just stretch up a shot from a drone camera because it would get all pixelated. So we had to do this kind of tiling system where like we're showing multiple copies of different variations of the same image in different parts of it, and kind of applying effects on top of that to kind of blend it together. And all of this is based off of like I think it's weather data and some oceanographic data, tide data that
data and stuff,
it uses to like pick between different sets of content. So we have like a daytime and it's hot library of content, and nighttime and it's cold, and it kind of navigates through this big library based on the current conditions and arranges those into different patterns onto the display.
Do they update the video library as well, or is that kind of a finished piece?
The others that I've done with them, it's kind of a finished piece that just runs for however long this they've maintained the screens.
Mm-hmm.
Yeah. I have been involved in some of their efforts of like going back to an old piece like 5 or 6 years later and like loading in some new content, but it's not like continuous kind of updating.
Mm-hmm.
But is it procedurally mixed, or is it rendered video in the end?
Yeah, so it's all like has a library of like clips of drone footage and a library of like full screen animations, and then it does the layout and mixing and sequencing and pairing of different things with each other, all dynamically.
So there's a PC behind the scenes doing all the logic and mixing and everything.
Yeah.
Never repeats.
Right.
Very
cool. Beautiful.
Mm-hmm. Really nice. And then Portal, Night on Broadway, that's one of your little passion projects, right? Looks like
this was a annual outdoor public free event in LA that was happening. I think 2018 was the last year that they did it, but we got a grant to do this street level installation with these two big projected panels, and we put a little camera right in the middle, and we had like a set of content also from Sebastian Peschiera that was these like kind of very abstract kind of fractally forms, and we were mixing that with this kind of tiling of the like whatever was coming into the video camera. So it would have a bunch of different copies of the video kind of in a U shape and with different amounts of delay on them. So when you go in front of the camera, you first see yourself on one side, and then you kind of like it swings around, and then you show up a few seconds later on the other side. And yeah, people responded a lot more. Like I didn't anticipate how much people would get excited about like seeing themselves in a piece of art, but yeah, people loved it.
Look at it.
Yeah. And, you get like, clusters of like little kids going up there trying to like reach up to the camera and, running back and forth. And yeah, it was really fun.
Super nice. Really cool. People love seeing themselves.
What's the whole, I see an interface that's familiar and an interface that's not familiar. What's the interface that's not familiar?
It's like a Resolume, right?
I think there might be a Resolume somewhere in the chain, but the main one that's on the screen there is my one of my earlier kind of big TouchDesigner projects was this library of 2D video processing modules to kind of provide an interface similar to Resolume, but with, you know, the customizability that you can get in TouchDesigner. So it was kind of a stack of these like 2D video processes, starting out with the camera input and then ending with this 3D render of the sequence of panels wrapped around.
Your own personal VJ app.
Yeah.
One particular output. Cool.
Yeah. So this is sort of your 10-year anniversary of using TouchDesigner, right?
Yeah, I guess so. I hadn't really thought of it. Well, no, it was.
I thought wasn't it Amin Tobin? Wait.
Yeah, it was just 2012, right?
2012. Yeah. So 10 years.
This was in 2018. Oh yeah. So now is my 10 year.
Now is your 10-year anniversary.
Yeah. It's I saw that. I didn't even see the original live show. I saw the second series of them, but I saw videos of it and it just blew my mind away. And, you know, I saw like a behind the scenes interview with like Peter Systrom, and there's kind of a screen in the background, and I kind of paused it and zoomed in and like tried to figure out what that was, and then found Touch and started playing around with it then.
It's amazing. Amin Tobin, I mean, people typically when we ask people, you know, how did you first hear about TouchDesigner? Amin Tobin is a big one.
Yeah.
Plastic Man, Richie Houghton's Plastic Man is another big one. Karsten Nikolai is another big one, and the whole sort of raster noton of old. What else? Those are sort of the three kind of sort of famous sources, I would say.
No, Deadmau5 too is kind of.
Oh, Deadmau5.
Oh, yeah.
Deadmau5, exactly. Yeah.
As
More
the
recently.
the newer one, yeah.
Yeah. But so many people say, oh, we were looking at the behind the scenes video and zoomed in on the screen and like, what is that?
Yeah, totally.
So
Why not brand their stuff out there enough? I mean,
it's
I think
then
subtle.
I went looking for it afterwards and found some articles mentioning TouchDesigner and stuff.
Yeah.
But first thing I saw was just like that interface on the screen, and that was the first projection mapping I'd ever seen, and it was.
So before we go,
sorry, one more thing that reminds me there. When setting up Grid, which is also a big white void.
Oh yes, of course, Grid.
A big TouchDesigner thing. Robert Henke was doing the audio, was doing an interview, and very naturally he put the about screen of Ableton on before starting the interview. So something you should just think about when
Right.
Yeah, for sure.
Yeah.
So before we sort of do live, I just wanted to ask you, we can still talk about the latest build because it's the latest build, and I'm just wondering what in this build is sort of been sort of really useful to you, or
so the Vulkan build, the transition to Vulkan was like a little bit rough. There were a couple of like in the very first experimental version, there were like a couple of rendering issues, but those got cleared up pretty fast. And there's just very recently build that pretty dramatically speeded up the like shader compile time like by a major factor, which is one of the main pain points of like while you're working with RayTK. It's when you do certain things, the whole process will just freeze while it compiles the shader. So that got like dramatically faster. And that's kind of the biggest thing. I think annotations and like network boxes have been really good for just like keeping track of stuff myself, but also when I'm doing tutorials and I can kind of lay out the boxes on the network with a name, and then as I'm going through the tutorial, I fill them in with the different operators, and it's like a template, and it's been great for the snippet examples of being able to kind of put descriptive text on things and say, you know, these operators are doing this, and this one is like this for these reasons. And I had been doing that with like DATs before that, which worked okay, but definitely looks a lot nicer now.
So, like, can we move to looking at RayTK and seeing how you actually build this stuff? As a, I'm part of the masses, so I'm curious to know how the masses avoid GLSL and doing ray marching and sign distance fields.
Sure. Yeah. Let's dive in. So the general idea behind RayTK is that you connect a series of these operators, which then get terminated in a renderer, which takes information from all of the things that are connected to it and compiles that into a shader, and then it runs that. So there are a few different renderers which use techniques. One, and so the scene is called the sign distance field, which is how you define shapes. And so there are a couple of core shapes. Box is one of these. So and see it's like kind of cube thing. And so there's a chunk of code that defines where this shape is in space, and then the ray marcher, as it's going through its process, is calling this code to figure out when it hits a point on the surface, and then it does some more stuff to figure out what color it should be. But general idea is that an operator answers a question about a point in space, and for SDFs, the question is what's the closest surface to this point in space, and the answer is a distance of how far away it is, and some other properties of the surface, like what material it's using, and so on. And then you have a series of transforms that are filters that can modify it in different ways, including some transforms. And this is a lot of stuff, and some of these are kind of equivalent to things that you see in SOPs, but some of them are things that would be pretty difficult with SOPs. And what they do is rotate, for example, when the renderer asks it about a point in space, it first applies some rotation to move that point, and then it asks its input what the closest point is, or closest surface is to that moved point. So it has the effect of moving the shape. And so you get the whole stack of those chained together, and then some options for combining different SDFs with each other. So there's a helix one here, which is this kind of infinite spiral shape. And then we are blending that fully with this box range 8. So you can see when it gets close together, they kind of smoothly blend into each other. And that's the kind of stuff that is pretty trivial to do in ray marching, but very difficult to do with traditional geometry. Then there's a whole material system where it figures out what color each point on the surface should be, and it does that by looking at what angle lighting is coming at it, and what the properties of the surface are, which direction it's facing, where the camera is, and all that, and figures out colors based on models of how lighting works on surfaces. And there's some kind of familiar ones. There's a Phong shader, material that's pretty similar to FongMat. There's a PBR one that is kind of a simplified version of the Touch PBR mat. And then there are a couple of other kind of more novel ones.
So as I understand it, when you apply material, means it's now easy for you to figure out the normals and shading based on a Phong model, but the texture coordinates are sometimes hard to generate or keep still and stuff. So you just kind of make approximations. But in this case, your texture is a procedural stripe, but you end up with some form of UVs along the way, or UVWs.
In some cases, yes. This is kind of one of the one of the main requests that I get is around applying textures to surfaces, and the challenge there is that there are no points or geometric primitives involved. Like it's all a mathematical formula that describes a shape. So for some kinds of shapes, like the box frame is able to do it, and a sphere is able to do it, but like many of the others aren't. And so they will kind of attach when it provides an answer about a point in space and says, this is the surface and this is how far away it is. Some operators will include UV coordinates in that. But once you start blending and merging and transforming things, like the UVs don't necessarily move along with it in the way that one would anticipate. And so it's not like you're taking the final shape as you're seeing it and then wrapping UVs onto that. You're like producing UVs as part of the math at the beginning of the process and then kind of carrying those through a bunch of transforms. And sometimes they remain in a reasonable pattern and sometimes they don't.
For your primitives that you like, the first one, the box one, let's say, with the transforms, like what out of the first one, which is it's the box frame SDF, like what comes out of there? It seems like, just looking inside, it looks like what comes out there is a couple of parameters, I guess. Oh no, just basically a pointer to the code that represents it. Yeah. And a pointer to the parameters, I guess. I mean, I guess it's synonymous, but you don't send very much from node to node. It's very lightweight.
Yeah. So the thing that passes between operators are these DATs with tables that are called definitions or operator definitions. Yeah. And they have a bunch of properties like, a unique name, the path, what type of operator it is, the type of coordinates that it's using, the type of value that it produces, and then a path to this, and then paths to a bunch of data that's generated inside of the core, which includes things like a chunk of code and all of the parameters packed together into a chop, and lots of other and kind of material identifiers and other such things. So, and when an operator like a assign color here is taking in an input, and in this case it's taking in two inputs, and it produces a table that combines. So here it's got the box frame, and here it's got the other two that are going into it, and it tacks its own onto the top of that list. And so every operator, as you're going through, just tacks on more items to that list, and by the time it gets to the renderer, you end up with a big table with a bunch of different operators in it and indications of where to look up their settings.
In some cases, like these tables might be better shown transposed, especially the earlier ones with fewer rows, so you can actually see more stuff on, because this is really a lot of text to look at horizontally, but if you apply a transform that to it, you can see more clearly what's actually being sent.
Yeah, it's
transpose rather. Yeah, transpose.
Yeah, it sort of depends on the scene. Like there are definitely a lot of scenes that have very large numbers of operators, and like there used to be a lot more columns, but they've since been kind of shuffled around a bit. The general idea is that, like, as far as the user is concerned, this is just like an opaque block of data. So people generally, like, there isn't usually a reason to look at the content of this, like, aside from, in a development context. And so then all of those definitions get packaged up, and then this whole big network goes through all of those and compiles together all the pieces of code and declares uniforms and aliases to variable names, and then spits out a whole bunch of code, and then some settings of uniforms of like this parameter array. Here's the chop where the values are collected, and if you're using textures, it'll produce those, and then those all get kind of pushed onto this the GLSL multi-top, which does all the rendering.
Clean and easy.
Yeah, I mean, clean is kind of
Are we now in the render Mark 3D component?
Where everything goes together, where everything comes together is a single GLSL top. That's it's amazing. Yeah.
And that's kind of one of the like performance challenges, is that it's basically doing almost all the work kind of in one step, which, I mean, it has benefits in that, like, there are, data, like a lot of data isn't like bouncing in and out of the GPU a lot, but it does mean that if, like, when that shader changes, there is a large volume of code that gets passed to the GPU driver that has to compile it, which can cause like a stall.
So if I just change a parameter, does that also stall, or is that?
No. So that will, let me pull up parameters here, and then look at, so the parameters get passed into a chop that then gets put into, so the parameters all come through like this, and here we've got like, well, we're animating those, so they're changing. It's somewhere in here, hard to see, but so those all get put into a chop. So the shader itself, the code doesn't change for this kind of parameter. There are kinds of parameters that do involve a shader change, and typically those are menu parameters. So not all menu parameters do that, but many of them do. So here, if you change the UV setting there, it will stall for a second while it's recompiling, and that's because
it's doing a code change.
Yeah, and because it's kind of it's sort of an optimization step where there are, so for example, these materials for diffuse shading, right? There's like lots of different methods that it can use, and specular is the same thing. And with being able to switch those at runtime without it having to recompile involves putting out this large block of code, and then a parameter goes in that switches between them. But
cool. So you avoid compiling if you have a big switch like that.
But that has like a pretty significant impact on runtime performance. So there's an alternate approach where it will just use only the code that you selected, and currently it's switching on that between whether the parameter is marked as read-only or not. So if you go to, not read-only, it has the big switch, and then you mark it read-only, and it will just cut it down to only the part that it's using. And so that's kind of a way to sort of selectively optimize parts of the network. And for a lot of kind of numeric parameters, you can also mark those as read-only, which will treat those as basically like a compile time constant. So that's useful for things that aren't going to be changing, and that doing that for things that you aren't going to be changing a lot reduces the number of parameters that have to get passed around, and seems to have a pretty decent amount of impact on runtime performance.
So you have a palette, like you have something equivalent to the op create menu. And that's kind of where a lot of people, well, most of us can just choose things from there and kind of combine them. Can you show how that kind of works in practice?
Sure. Yeah. So there's the Alt-R shortcut that pops up in the palette. It lists the different operators grouped into categories. And for some of them, it has a thumbnail image. Not all of them. There are some things that are kind of hard to represent in a thumbnail image, but and you can search for it. So if you want to create like a sphere, create a sphere operator, and then where did that go? and then connect that up to the renderer. You get a sphere as your geometry there. And so this is kind of the main way to create operators, and when it does that, it kind of applies some cleanup to them, so it makes it only shows the custom parameters, that you're not seeing a lot of extraneous stuff in there. So it's only the stuff that's kind of relevant when you're working with this as a user. And there are also a couple of shortcuts for so here is a what's called a modular material, which is where you can combine a couple of different shading models into a single material. And there's an Alt-Shift-R shortcut that has some context-specific actions that you can take. So in this case, if you wanted to add another diffuse shading one with Lambert shading, it will pop out another one of those operators and connect it to the next available input. There's other stuff for adding a conversion to a different data type, or rescaling a vector's values, or adding an animation. So if we go to, let's say this wave field, which is part of what's determining that blue and green striping there. If you select that and pick this animate with LFO and choose the amplitude, it will create one of these kind of helper components that is basically just a wrapper around a bunch of chops, and it will apply that onto a parameter to kind of quickly add animation to it.
And how come there are 4 channels there?
That is a bug in version 0.27 that is fixed in
okay.
the next one after that. But if you're animating with the speed approach, it just does a single channel.
Yeah. Okay.
Yeah.
All right. So among the primitives, there's kind of growing, well-documented set of primitives in the SDF world. Is that kind of what you have here?
Yeah, so this is largely pulled from Mercury, which is a demo scene group that did a library of SDFs and some kind of related transformations. So a lot of especially the kind of earlier stuff that was added comes from there. And Inigo Cluez on Shader Toy is responsible for a lot of the other stuff. So he's been putting out these shaders and writing articles about different SDFs that you can use. And so a lot of these operators are basically taking a chunk of code from Shader Toy and packaging it up and adding some parameters to control it. That's where a lot of these, different shapes come up. And when Inigo adds another shape, it'll typically show up here in the next version, because I tend to watch for those. Some amount of it has been, so it's kind of been, it's been a bit of a learning journey for me, because I think I don't have a strong grasp of a lot of the underlying math, but I've been kind of picking it up as I go. So it's been a mix of copying and pasting code, but then finding ways that I can modify it. And that's been how I've been learning about how to create different kinds of SDFs myself. And so as I've been going and picking up more knowledge about these things, I've started to be doing kind of authoring original code more as it goes along.
Right. We've been taking a lot of the examples and poking at it and see what they do, and try modifying parts of it and see what that does, and then you kind of learn basically the math behind it through experimentation, really.
And I also have a question. What we're seeing right now is a very organic way of 2 shapes kind of going into a union there. Is that a function of how SDFs work, or is this a specific operator that you have?
Yeah, so that is I can put together like a simpler example here.
Actually, if you don't mind, I think we skipped over that step. You start basically by pulling in this one TOX that you can download from your GitHub. And then you press Alt R, I believe.
Yeah. So when you drop it in, it shows up like that. You can put it wherever you want in the project. I put it here because it cleans up the network a little bit for demo purposes. But then this Alt R, and you can start laying out operators there. So create one of these box frames, and then use another one of these shortcuts to add renderer, and then add a camera, and add a null top to the end. And so we've now got, a view of our box. And if we can, you can move the camera around and get a different view. And then, if you want to be combining different operators, different SDFs, you can select multiple of them and pick combine. And then there's a bunch of different ways that you can combine them with each other. So there's simple union, which is basically just like both shapes exist, and in places where they overlap, it doesn't do anything special. They basically just kind of meld into each other, like with a hard edge between them. But there's also, and then there's, intersect, which will only do the places where they overlap, and difference, which subtracts one from the other, and you can, flip it. And then there are ones that apply some amount of blending in the places where the two overlap. So you can do this smooth blending, and you control like how much it blends between the two. And it's able to do that because of how SDFs think about space, where they're basically just a way to answer a question about a point in space. And if you have, so that when this combine operator is asked that question, it grabs the two answers from each of its inputs, and then it has those two distances to work with, and it says like, if a point is a certain amount of distance between those two, then it is kind of filled in as a blend, and if it's further away, then it's not. And it kind of, it combines the two distance values, and that produces like a shape that is the result of combining the kind of conceptual shape.
That's a huge amount of flexibility that you don't necessarily get with subs at the moment. The other thing that I found was that a lot of these operators have also field inputs, where it's almost like you can actually apply these effects on a per, I don't want to say per point, is it a per ray, or how would you express that?
It's basically so fields are, let me just turn this off for demo purposes. So fields are basically a way of modifying a parameter depending on where it is in a point in space. So if you do let's do a rotate, and we're just going to use axis rotation. So it's just rotating around the y-axis. So, just goes like that. And you can use what's called a field operator, which produces, when the renderer asks it a question about a point in space, what it produces is just a number answer. So if you use that number to drive the amount of rotation, so here we're doing a kind of sine wave along the y-axis, and if you let's stretch it out a little bit more. So it when it's asking about a point in space, it will first look at, it tries to figure out how much rotation it should apply, and when it does that, it asks this wave, which says, sine wave, y-axis, here's how much rotation you apply here, and then it does that before it passes the question along to its input, first input. And that answer differs in different places in space, which causes the amount of rotation to be different in different points in space. And it's functionally infinite resolution, because it's a formula and not a set of points. So it will produce, it just takes the y coordinate and applies a sine wave to it, and that's the amount of rotation. So wherever the renderer is asking about in space, there will always be an answer for that point in space that's like, specific to that location. And so there's a whole bunch of different of kind of fields that will provide have different ways of answering that question about points in space.
So, like with the, go ahead, Marcus.
Just the last question would be, those fields are also fully animatable, so that is another.
Yeah. So if you change the phase of the wave, then you get the amount of rotation is kind of shifting based on a wave that's being moved up and down. And so there's a lot of control that you can get through that. In a sense, it's kind of like the Luma blur top, where it applies a different amount of blur based on the value from its second input. So you can, blur to different degrees in different parts of the image. So it's kind of like a three-dimensional version of that.
So in terms of combiners, it's kind of like the composite top in a way, but what other combiners would you have? Is there another node that has a different kinds of combiners aside from the batch that you have here?
Yeah, so there are a few different ways to like use this standard set of operators or of combine modes. So this one is kind of specialized combining two of them, and its additional inputs are for like varying how much blending and some other settings. There's also the arrange operator, which is, it takes in lots of different SDS. You can apply different translation to each one. You can switch them on and off quickly. So it's kind of a way to like mix a bunch of things together. And then there is compose SDS, which is, you get some number of inputs, and you can pick, here I want to use input 3 with, smooth union. Here I want to use input 4 with, this offset in space and subtraction or something. And so those are kind of just different packagings of that same set of combinations. There are also some more kind of novel ones, like the edge combine, which does, let's see, let me get a box and swap that in there. And let's move that over. Okay. So edge combine can do things like cutting a kind of groove into, so it's not showing the sphere, but it's like it's using the sphere to know where to cut this groove into the shape, and you can have it, extrude a part there, or, it can have it only show those, like that overlapping region, so you get kind of a tube. There's also a bunch that are taking a 2D SDF, and using it to create 3D shapes. So there's, so we do like a star SDF 2D, and a revolve. This will, let's see. So this will, and if you push this out there a little bit, so you've got this star that is basically being swept around an axis and to produce a 3D shape. There are a few combiners that do something similar with, shapes combine. These are some of the more like esoteric ones that are not used as frequently, but and combine those. Something's going on there. Okay, well, general idea is like there are ways that you can use one 2D path as the kind of path that you sweep another 2D cross section around to create a 2D or 3D form, and yeah,
Interesting. So in terms of like in TouchDesigner instancing using chop channels or
so that is
there some form of that here?
Yes, with a caveat. It exists, but there are some pretty significant limitations performance-wise. So if we do, so there's two kind of ways to, let's say we've got the sphere. So one of the ways to kind of do something that's like instancing, but not quite, is to use these spatial repetition ones. So this is, and you can kind of separate them out. So this is repeating space and not the like. So it doesn't ask the sphere, multiple times when it's coming up with its output. It just shifts the position that it's asking about so that it repeats. But there's also an instance.
So that's faster.
Yeah, so that's like effectively just as fast as having a single sphere. And there are ways that you can use which slot it's in to vary the properties of the sphere, and do something like cell index and then add a wave field, and then so we can vary the radius of the sphere in different cells by different amounts. So go that and okay. So and then increase our period there. So then you can like have different. So you can kind of have the sphere behave differently depending on which sort of pseudo copy it's using. But there is also an instance operator. So this has a limitation that they can't overlap because it's basically like taking a slice of space and repeating it. So you can't have things that cross the boundary of that slice. But the instance operator, which let's say we can use a pattern, and we'll set the channel to X and say 4. And we can use the instance operator to call to, let's see, something's going wrong there. Okay. Some sort of error there, I'm not sure what, but general idea is like it'll repeat the work of the sphere multiple times and then combine the results, and that means that they're free to like overlap with each other, but it does mean that it's repeating everything upstream of it, 4 or 6, whatever times. So depending on where you put that in your network, it can really slow things down.
Right. But it's linear with the number of the copies or instances rather, right? So 100 is 100 times slower. Okay, got it.
But there are lots of different ways that you can do these kind of spatial repetition things that are basically cost-free. And so I pretty rarely end up using like the instance operator.
What would be other ways to do this?
There is a polar, which there's modular polar does a kind of radial repetition. So stick that in there, and we'll spread those out. Spread those out a little bit. So you get some number of copies kind of rotated around, and an axis. And yeah, there's also a 2D version of that spatial representation that puts things into like a 2D grid, and a 3D one that does a 3D grid. So, and all of those are basically like effectively cost-free.
Okay.
Yeah. So a lot of it, and yeah, there's like reflect to reflect it across an axis. So it's kind of a different, like there are some ways that you need to think about things that are kind of pretty different from when you're working with SOPs, where it's sometimes less about like placing objects and more about like reflecting and repeating things in order to get them into the right spots.
Yeah, and some of the effects are really have sometimes when first trying them, they seem to have unexpected results. Just the modular polar, for example, you had a pre-rotate, which really dramatically changes the geometry as well. So it's getting, I guess you're getting used to a different set of dealing with geometry.
Yeah, and there are, there are cases where like pre-rotation is really useful, and cases where like it doesn't do what you think it would. So if you have, something that is, if you apply mirroring, it tends to go a little bit smoother, but you can get like these kind of kaleidoscope effects in space. And so there's kind of like, there is a pretty different mentality to working with it, but there are things that are possible that like would not be possible without like in a traditional world.
Would it be a good mechanism for doing L systems in a way that you don't have to worry about the junction between branches and stuff like that? You just basically have a bunch of primitives that are organized at branches following the rules of L systems, but for instance, just taking something from the L system SOP and then descending it into something that generates lines that are blended together.
So there is a segmented line SDF where you can move around. Let's say we want like 4 segments, and we can move different points, and so you can kind of like do things like that. It doesn't. I mean, this is basically like right now. It's essentially doing the work of a line segment 3 times, and then combining the results. So it is another kind of instancing it approach. It doesn't the kind of branching that you would need in L system, but there are ways to do it.
And the simplest form, an L system is a set of lines with some attributes at either end, like thickness and color. And so that you just send out something that takes a SOP full of lines and just converts it into the proper SDF code.
Yeah, so that could definitely be done. It would be like you just need to keep an eye on the number of lines, but because the work will like scale linearly based on that. But the general like that workflow should work. It should be possible to implement that at least.
Yeah. In the render, is there any optimization of like spatial optimization of segmenting your data up into boxes or op trees or anything like that?
Yeah, so that's some of the stuff in when you're dealing with these like repetition operators can be used to do that. And you can say like, let's see if you have like a, a sphere and a box, you can have it, I'm getting a have it like switch between different shapes depending on which slot in the repetition it's dealing with. So that way it will need you the work of one shape and it picks which one to do based on where it is in that text string.
Right.
There's another like more general approach to bounding volume optimization that I haven't gotten the like kind of general form of that working well yet, but it is on the list, and it's kind of, I have like a partially working prototype of it, but the idea there is like, if you have this really complicated thing, but you know it's always going to be within the sphere, you can first check to see if the point is in the sphere, and if it's not, then you don't have to do the work, and if it is in the sphere, then you know it does all the complicated stuff. So it's possible to do it. I just haven't implemented it in like a general purpose way.
Right.
I got a question. I got a question from the chat.
Yes.
So Tim Gerritsen is asking if it's possible to use randomness and noise.
Yes, there are a bunch of different noise operations. So we can do let's go back to our box frame and can do this called a round operator that basically like bulges a surface out or pulls it back in, and then we can drive that with a noise field. So we have there's a bunch of different options. There's like curl noise, just a little bit heavier. And then there's the standard noise field, which uses the Wombat library, which I think is used in like the noise component in the TD palette. So it has lots of different like, you know, simplex and Perlin and this like cellular noise. And then you can kind of move that through space and have it apply to different attributes of things.
Very cool.
And what other rendering effects are there? Do you could you even do shadows in there, or I mean?
Shadows are effectively free, or well, no, they're not that free. They can be quite costly. That's a misstatement, but shadows are like the logic behind it is pretty straightforward. So if we do a combine and then combine a couple of these, the plane, and then connect that so we get something to put the shadows onto, and add a light, move it up side, and then on the renderer we can switch on shadows and move this light somewhere else a little bit further up. You can cut shadows, and there is an option that you can do kind of smooth shadows, or it softens out the edges, but it's a little bit buggy. That's that's on the list of things to fix, but this kind of hard shadow is pretty straightforward to do.
And it's also self-shadowing. That's nice.
Yeah. So it's basically like there's no limit to like the resolution of the shadow, because it doesn't, and it can intersect with. It doesn't matter if like one, because as far as the scene is concerned, like there is only one SDF that is the combination of those other ones. But by the time the scene cares about it, there's no like separate geometry that it's dealing with. So any part of it can block light for any other part of it without having any complications.
Interesting.
Well, so far all the questions have been from our end. I'm just wondering, Tommy, if you have any questions for our guys.
Sure. Yeah.
I mean, could this be any better?
In lots of ways, I'm sure it can. So I guess one of the more maybe like mundane questions is about parameters. So right now, the parameters are all being passed in basically one stop uniform array. There are some that are like kind of compile time constants and stuff, but like for anything that's basically like a number that you can drag around, it all gets packed into one big array. And I've gotten part of the way through implementing like splitting out each each one has its own separate uniform, but like they can get like right now we only we only have 85 samples in this vector, but like it can get up to 100 or 200. And I don't know whether there's any benefit to passing them in as individual uniforms versus all in one big array, or
The single array is definitely faster.
okay.
It would be significantly faster. So
Okay.
if it's less user friendly, right? But since you're hiding that already
Right.
behind, then you're definitely better off keeping it as a single array.
Okay. I've read some stuff that like in certain cases, if the compiler might be able to treat certain things as being like constant-ish, even though they're passed in as a uniform, but which I don't think would work with an array. But if that's not real or not what I think it is,
not for anything you declare as a uniform, because there's no way for the compiler to know that. Because
right.
Servicing the uniforms is entirely separate from the compile stage.
Okay.
Vulkan does have a concept of something called specialization constants, which is a uniform that you specifically denote as a specialization constant, which is a compile time constant.
Right.
That when you compile it, you also need to provide values for those. And then if you decide to change it, then you have to resubmit the shader to the graphics card.
I mean, having that exposed would be pretty useful, because right now I'm doing it by generating a lot of defined statements that get shoved into the shader code. So here, like this, whether to use the light color in this diffuse contrib is like passed in as basically a macro that then gets used further down. But
I don't know if you would want to replace those, because it's right now, like those defined statements, they get pre-processed, and then that more efficient code is what ends up getting sent down to the compiler, right? We don't know what the compiler is going to do with the specialization constants. It may just kind of make it as a faster uniform, which won't be as good as actually a compile time constant.
Okay.
But for cases for like your switch statement, for example, that you had back a while ago, right between the different materials, we'd have to test when I expose specialization constants whether or not the compiler realizes that it can kind of throw away all the switch statement, and it always knows which path it's going to take.
Yeah.
Right. And so that would at least kind of avoid sending the full shader back through the compiler, and you just have to submit it.
Right. Now, here it's being used as like let's find a cleaner example, but here, this one's a good one. All right. So if this is resolves out to like a preprocessor macro with a constant, like does it know to throw out the other switch cases?
We'd have to check the resulting compiled code. Quite possibly, yes.
Okay.
Cool. Yes. Generally, that's the way. Like whenever I can use a compile time constant, that's done using define or preprocessor define. I do, and I assume that the compiler is going to handle that for me.
Okay. Because right now, like there's a chunk of Python that kind of does this, like for switchable parameters. It will kind of do either runtime switch or like just only the specific chunk of code. But I mean, I guess that's probably still preferable to like outputting a switch with a constant in the like this like just outputting the one case is probably going to be faster than like doing a switch and assuming the compiler will know to. Yeah,
we have to like it could be. So to give you a little background, the way it works with Vulkan is essentially you take your GLSL code. It's first run through a preprocessor, which resolves all those preprocessor ifs and stuff, right? And then it's run through a offline compiler that creates something called SPIR-V, which is essentially an assembly language, right? That it's a generic assembly language, right? And so that's the thing that we give to the driver, and that along with the specialization constants is what's given to the driver, and then the driver does something with that.
Right.
SPIR-V is already run through an optimizer, which is probably one of the slower parts of compiling these shaders. Yeah. Whether or not the driver then also runs it through its own optimizer, right? We don't know.
Right.
And what it does with specialization constants, what it does with switch statements that it realizes are just constants is kind of a black box to us, and so we have to kind of see what the performance is like.
Okay.
Right. So like when we kind of dive into this more, like the question is where does it end up after it's gone through the offline optimizer, right? Does the offline optimizer catch the cases that we're hoping for, like the preprocessor switch statements, which are actually constant? And then beyond that, if that doesn't, then we can see whether or not the graphics driver compiler does something with that.
Okay. Yeah. So that, and I guess that I think another sort of offshoot of that I think you've answered before in the past is just like, do I need to, is the preprocessor process, like, do I need to worry about performance there, or is that a tiny fraction of the compile time?
I think you should do as much as you can in that stage. I think that's going to be quite super fast.
Okay. Okay. So I don't need to like worry about having too many macros or like, too much complexity in the preprocessor.
We'd have to profile it, but I don't think so. I think the SPIR-V optimization is probably the most expensive part of the process.
Okay.
Because there's like 20 or 30 different optimization passes that it's sent through.
Right. Okay.
So Malcolm, explain the stages here. Like the GLSL Lang is developed by a third party and it produces SPIR-V. Is that right, or am I way off?
No, that's correct. Yeah. So GLSL Lang, which is the tool made by Kronos, you give it GLSL code and outputs Vulkan compatible SPIR-V.
Right. Okay.
Yeah. Okay. And that was where that recent optimization was, or.
Yeah.
Cool. Okay.
Yeah.
I see.
Yeah.
I see.
Yeah. And in particular, that was in the SPIR-V optimization pass, which is kind of a sub tool, which is GLSL Lang will execute.
Okay. So another kind of deeper shader question is
deeper. Holy Jesus!
I mean,
I'm drowning.
In some ways. So each operator like ends up primarily producing like one primary function. So here it's like look at camera and it gets like a UV pixel coordinate and produces array, which is direction or whatever. So every operator's like main function has this signature of like coordinate type and a return type, and then what's called a context. And context is like in the case of camera is probably a bad example, but for like material, right? So here the like diffuse shading element gets this like material context, which is what contains like the surface normal and a color setting for the surface and all this other stuff. So basically every call between operators ends up passing around one of these context structs. But in a lot of cases, like they don't end up being used. So like if we go down to like when the helix, when it calls the helix to the renderer passes in a context struct, and then when it calls out to things like if there's a field that's controlling the thickness, it passes the context to that, and that passes the context to its inputs and so on. So do you know if there is a cost to like passing around structs like that don't end up being used?
I don't think so, because like the shaders don't really have a concept of a stack.
Right.
Like a GPU. So it's not like it's pushing variables onto a stack and then calling a function. Most of the time, functions just end up getting inlined through the compilers, and ends up just being a single long function, which is just running code.
Right.
So, and if not, it's kind of referencing global variables ultimately.
Okay.
So I don't, or look at more, maybe not global variables, but like local copies and stuff. If you end up modifying it potentially.
Right. Okay.
So for the most part, I don't think that will make a difference. I think kind of the real way to know is if I had a way to output the SPIR-V code, and then you can actually kind of look at somewhat human readable assembly, and then kind of get an idea of what it's doing there.
Yeah, I think there's an NVIDIA tool that you can do that to like test the shader, but Yeah.
Inside graphics, you can attach that and you can see the shaders.
Yeah.
That's another way of doing it. Yeah.
Okay. Let's see. So,
hey, Tommy, do you want to take a question break from the chat?
Yeah, sure.
So can RayTK be used for architectural design?
So this kind of butts up against one of the limitation areas where, in terms of like prototyping and creating forms and coming up with ideas, like definitely, getting like geometry out of the system is a bit more of a challenge. So there's often a question that I get about like, can I export this as an FBX file or something? And right now, there is no actual geometry involved. Like it's all just math formulas. So you can't like just directly export like that. But the one approach that I've thought about is kind of doing something similar to that volumetric LED grid, where there's the point map renderer will, like, you can give it a grid of points and it'll, for each point, it'll say inside or outside of the shape. And you can export that as a SOP and then try to wrap geometry around that. I don't know if there's an efficient way to do that in TouchDesigner, but Houdini can do that part okay. It's not a real-time process, but like you could use that as a way to get a model out that you could then, work with in other tools. But it's not a direct process.
Like the shrink wrapping method of
So you get like, you end up with like a bunch of points that are like that are inside the shape, and you delete all the ones that are outside, and then you can like wrap geometry around that for now.
Yeah, we don't have that now.
Yeah.
Yeah. So in the same vein, it'd be hard to say put this ball on top of this surface. I mean, you don't know where the surface ends, kind of thing. But
so it is possible to combine traditional rendering with RayTK. So you can share cameras and lights between the two. So there's like a special like linked camera that basically binds to a regular TD camera and kind of mirrors it. And then you can, in the renderer, it will use the depth from a traditional render top as a way to block out parts of the RayTK thing. So you can then just like layer them. So you can kind of like combine you can put RayTK things in other scenes, but like they won't, like the other geometry won't like cast shadows on the RayTK stuff, or like they won't interact like that, but they can be spatially in the right locations relative to each other.
Yeah. Yeah, in terms of doing even depth compositing of a 3D TouchDesigner render top scene with RayTK scene, you need to, in the simplest case, you just need a depth channel of both to combine them into one rendered thing. But like you say, they wouldn't share shadows or things like that. It's just kind of merge them together. I don't know if you've tried anything like that.
Yeah, that's basically. So there's one of the tutorials on that. Let me pull up one of the test cases here in the development tool. And okay, so here we've got a render top that's putting out like a cube there, and then in this Raymarsh renderer, we're like using the depth from that, and it produces this an image with certain parts blocked out based on the depth for the renderer, and then you can like mix the two to composite it together. And that's like it works fairly well. There will occasionally be like errors, like a little bit, like some geometry errors, like they're kind of intersecting each other a little bit strangely, but it's usually pretty usable.
How about if you gave it like a depth image, say don't render anything past this point, but it's basically a Z coordinate per pixel. Is that the same thing?
Yeah, that's basically what it's doing. So it's grabbing within the renderer, it grabs the like depth texture from the render top, and then it passes that in and uses it to, like, once rays hit that depth, they stop and are basically tossed out.
Okay, cool, good. Okay, at least there's that.
Is it fairly simple to, when I see this, because now you're mixing TouchDesigner rendering with RayTK rendering, is it simple to hook up cameras?
Yeah. There are, so right now, it's just using a, that's not going to help, but so this is using a camera comp, and so you can enlarge that a little bit. So you can kind of share a camera between the two. And it does that by, like, there's a special linked camera RayTK operator that grabs the matrix from that camera and then uses that for the ray marching parts. They line up. And there's an equivalent one for lights. So if you move light placement, it'll affect both shapes or both types of rendering.
Cool. Okay, so they're linked cameras.
Yeah.
Can you answer like something I've been noticing which I can't figure out?
I think your audio cut out.
I'm sorry. Your RayTK components, like let's say RayMarch Render 3D, all of them, they're all base components, right? And yes. You have custom parameters on tabs and stuff like that, but you can't see the built-in tabs.
Yeah.
How do you do that? I should know. Is that a feature of TouchDesigner?
Yeah, it's the show custom only setting. So here in the development environment, you see the full thing. So there's like the extension comment and stuff. But as part of the build process, it switches on that setting for all the operators.
Oh well, is that a Python flag? Okay. Yeah. I didn't know that. Not many people probably know that either.
Yeah, I don't think it's used commonly. It was the source of like a kind of weird bug where the parameter panel would expand, but it only did it when that was switched on. So I don't think a lot of people use that setting. But
I was trying to figure out where you get your viewers for your nodes, like your logo, or basically your image that goes into the viewers. And I think, how do you find out where the viewer is and so on? So it would be visible.
So you get so if you look at the properties of the parameters in the development tool, then you look into there's like the inside object definition. There's
so operator viewer says what it's inside there. Yeah, // Okay. Cool.
So can we just keep jumping all over the place here? I have another question. So we were asking Chris Northern, who was briefly in the chat, briefly watching. I think he's gone. He did all the really cool plotting stuff with RayTK.
He's really pushing the bounds of what
it's used for. So Pete Thornbury was asking, how are you getting stuff out of RayTK for the plotter? Like, do you know, is it vector based? Does it still involve?
It's it does like a RayMarch render to get an image, and then I think it's a bit of Python that like kind of vectorizes that image into like an SVG, and I think that's what gets plotted.
So it is possible to get vector-based stuff out.
Yeah, I mean it's kind of it's a vector version of the 2D image, so it's like not based on it's not like the shapes, the original shapes. It's like how it looks in the image, but you can still use it in a plotter at that point.
Okay. So basically vectorized off of a raster.
Yeah.
Hey, can you show your snippets palette as well? There's a whole bunch of amazing examples in there.
Yeah, let me pull that up. Hold on just a sec here. Yeah, so the snippets are a pretty recent addition, and they are in a separate talks file that, we'll do that. And I kept them separate from the main toolkit because they are like significantly larger than the original toolkit itself. The current build, it's like 37 meg, whereas the toolkit itself is like 9. And it can take a little while to load because it's doing the like shader compile partially, and there's also just a large number of operators in there, so there's some overhead there. But once it loads eventually, and yeah. Yes. Yeah. Yes. Yeah. So,
hey Marcus, hold on? Is it bad if my window says 5 minutes left in your meeting? Warning.
Oh no, I mean, I don't know why.
Okay,
your window
just
is
FYI, we
Yeah.
might disappear. Okay,
No,
keep
it
going,
keeps
Tommy.
going. No worries.
Yeah. So yeah, for the snippets, it's been really nice here, for, like stylistically, but I've got a bunch of different, for many of the operators, not all of them, but many of them, there'll be separate like examples of different you can use it, and like this is, you know, showing combining two shapes, simple union, and doing an intersection and difference, and then here's doing it with a 3D shape, and then here's blending between the two, and you know, varying the amount of blending using a wave, and so yeah, developed like this. These like sets of kind of relatively self-contained little examples that show all the different ways that the operator can be used. It's fairly similar to like the test cases in the development environment, just with like its nicer presentation. But the idea there is you basically you have a bunch of different like iterations of it, each of the different features, and for the snippets, the demonstration for the test is verification for the build.
Nice.
Do you have any like art example snippets kind of thing, like stuff that may end up on the instance and stuff like that? Like, well, do people normally post their raw TouchDesigner files with the Instagrams? Or
yeah, so there are a few people. Perry has like a Patreon account that he puts out some like scene down like example files along with renderings and stuff. And I also have a Patreon where I do some of those like scene file downloads. Within the snippets, I try to keep them pretty like scope contained down to like the simplest possible way to demonstrate each feature.
Right, functional stuff. Mm-hmm.
But but my Patreon and like a lot of YouTube tutorial videos I have are like walkthroughs of building from scratch, and those are they're usually like I take one of the things that I've developed and been putting out on it, and then kind of clean it up, annotate it, and then like walk through creating it step by step in the tutorial.
Cool.
Yeah. Is sort of a concession from the original kit from Patrick Lickner was it had a renderer embedded in every operator, so there was a viewer and you could like mouse around and like rotate it and stuff, which is great for understanding what's going on, but it had like a pretty massive performance cost, especially when you had larger scenes. So as an alternative to that, I added this inspector tool, which it talks, and so you need to have, that's like one of the cases where you need to have the toolkit talks load alongside your scene in order to use this tool, but it will show it will show the like a rendered version of what the thing is. Not every operator there isn't a way to like directly a light or a camera, but for 2D like shapes and 3D fields, it'll do. And you can view different properties of it. So here it's looking at like the world XYZ position or the surface normals or UVs, which there aren't any, but looking at different aspects of it in this view. And this is using linked cameras and the camera TouchDesigner palette to do that mouse interaction. Is also then so that's kind of sort of just like looking at things, and then there's a bunch of other tabs for like here's the shader that the full rendered shader, like with all the generated code and stuff in there. You can look at different library files that get included and look at the individual the settings for an individual operator or different libraries, and like look at the macros and validation results and the definition table and lots of different stuff. That's like I'd say most of these tabs are pretty much for development and debugging purposes, but the like preview one is a way to like look at the network and see what it's doing independent of everything that comes after that.
Is the
shader, and nicely you're
just a quick question, the shader that you're showing there, is this the shader of the node, or is that the end result thing?
So when you are inspecting a like the actual shader, the renderer used, when you're inspecting like an SDF or something, it has its own built-in renderer that it connects up the SDF, and that's the shader that you're seeing there.
Including the parameters that you set?
It includes the references to the parameter names. So in this case, like you get a lot of these further down. You get these like which are their macros that alias into different points in the uniform vector.
You've lost your video.
What's that?
I think we've lost Tommy's video.
Seems okay.
Okay. Yeah, I don't know if Marcus mentioned that he's broadcasting from Berlin right now on not his normal computer, so you may lose us. Hopefully not.
Yeah, I do see all of.
Yeah,
okay, we're
there's
still
also a separate page where you can use all the parameters. Those are kind of separate from the code.
Yeah, and your button parameter goes to the help page in GitHub, so that's really nice.
Yeah, so that's a whole other part that we haven't talked about is like this documentation site where as part of the build process, it generates this big directory of markdown files with some like data annotations in them, and that gets dumped into the GitHub repository, which uses GitHub pages to publish it as a website. So there's within individual operators, there'll be some DATs that have like manually written help codes or help text. So if we look at here's Raymark's render 3D, those be like, here's the description of the operator and then the different parameters, and it dumps all of these onto the parameter help. So when you mouse over the parameters, it'll show that, and the names for each of the inputs and descriptions, and then part of the build process takes this and like adds anything that's missing in this, and so any parameters that haven't been documented, it inserts them in there, or for operators that don't have documentation, it generates a stub for it, and then that it gets dumped out into those markdown files and used for the documentation site.
Well, that's terrifically organized.
It took a little while to like get all that wiring to work, but now that it does, it's pretty reliable.
And I presume you can use the search in GitHub to search for stuff on these pages.
So, you can do like, I don't know, rotate. So find different pages that are about rotation and including, and so that includes like this like operator reference, but also some of these more like conceptual guides that are manually written out. And there'll be kind of links between the two. So if you go into like this one guide refers to one of the operators and it links to that page, and yeah.
So do you have more questions of us, Tommy?
So one of the other kind of infrastructure questions is there was inside every operator, there's definition, which has a bunch of stuff in it. There are all these ones that like process inputs, but definition, it is a bunch of stuff in there. So this is inside every operator. That was having an impact on weird parts of like editor performance. Like deleting an operator would take a noticeable chunk of time. And I think it was related, and I posted on the forum about this, but I think it came down to like there's some overhead involved in deleting every operator, and when there are hundreds of them inside each one, then that adds up. So I've started migrating to this approach where instead of generating lots and lots of different tables within each one, there's like a big script that generates this like structured object, and it puts it in JSON format. And then the renderer, when it's gathering up all the data for all the operators, will look at each of these and parse out the JSON and then grab the fields that it needs out of that. I don't yet have a good sense of like whether this approach of like lots of DATs or like one big script DAT is within those things, but yeah.
Yeah, I don't think there's a good answer to that. It really depends kind of where the zones are.
Yeah.
What you're trying to optimize for. Yes, and like if it's when you're deleting a node, for the most part it happens because there's a bunch of nodes that are trying to like resolve paths, or and like the number of nodes have changed, so they kind of recheck.
Yeah.
So like I think probably for that case is best if you can kind of give us a test case where it's like do this action, it's taking a long time, and we kind of take a look at why it's taking so long.
Okay.
But I don't have a great answer for which way is better.
Okay.
Unfortunately.
And yeah, so that's like in each operator that, and then the part that's generating the shader is kind of another case of that, where there's like lots of stuff. This used to be like significantly more DATs, and it would generate each chunk of code, each of the different, the functions and the parameters were each their own script DAT, and then that got merged, and I combined it into one, and then now since like most of the work goes on in one script DAT, I'm able to use the like time it module to do some profiling on that, and so I was able to like optimize some of the Python there a little bit and find some spots that were, but yeah, it's just, it seems like there's a lot of stuff inside every RayTK operator, and like that scenario doesn't seem, I mean, I guess widgets are kind of a similar case where like but it's like a different order of magnitude of the amount of things inside each one.
Yeah, and we are trying to reduce the number of nodes inside widgets in particular.
Yeah.
So yeah, there certainly is value in reducing nodes if you can, but there's always trade-offs between how maintainable things are, right? If you want people to be able to go inside these networks and kind of see what's happening and change in the future, right?
Generally not. Like in the production version, so I added all these annotations, but just for purposes of this demo, but usually like as part of the build process, that stuff all gets stripped out. And so it's hard. So this is basically not intended for like a human to look at in most circumstances. It's supposed to kind of just be like opaque, but
interesting. Yeah.
So another like
okay.
Go
ahead.
When dealing with parameters, I found that there can be some, like in Performance Monitor, I found there to be some lag in combining all those chops and sequencing them out into the array. And the way that it's currently done, it pulls up, it produces like this one big chop grab, like collected from all of the operators and where each parameter is a channel, and then it splits those into the different parts of each vector, and then it, turns those into sequences and then merges them. And so like this whole process, it seems like all of the work for this needs to happen anytime even a single parameter changes. And I had kind of tried another approach where each operator would pack together its own vector, like saying with 4 channels, and then the renderer would concatenate all of those. But it seems like it's another one of those cases where like you're trying to figure out which overhead is worse.
Yeah. Like another way would be to kind of group them in put all the X values in one row and then all the Y in another one, right?
Yeah, that's basically what it's doing. Yeah. It's just, where does it do that splitting up? Like in each operator where sometimes things may not be changing, or for everything all at once, anytime anything changes. But,
well, I mean, if you can split it, instead of, you have that select that has all of them right at the start. If you had 4 selects and the first one only grabbed X's.
Oh, yeah. Okay.
Maybe that would help you a little bit, because right now, because all 8 of those nodes need to cook right now.
Right.
And then you could reduce it down to only 2.
But you need the spacers in there. You need the spacers in there, though. You basically need every parameter displayed as a vec4 for this to work as it's going as an array then into the shader. So it would be a function of the parameter chop or something.
Yeah, so you get within the there'll be names and then these like placeholder ones that fill out missing spots. So there's a table that has a list of like all of the parameter names. I don't know, it's not the right one.
Wow. Yeah.
For each, all of the X parameter names, and then all of the Y ones with spacers to line things up appropriately, Z and so on. And then each one of these selects is like grabbing those channels, and then for the placeholders, it grabs multiple copies of it to kind of,
Yeah, another workflow that we could potentially add is a way for you to kind of fill in uniforms by name, but just passing it a chop. So it looks at the chop channel somehow, right? And then that way you're not filling a bunch of parameters, or not evaluating a bunch of parameters. We're just reading a bunch of chop channel values, which is much faster, right? So the only trick is how to deal with like the vector values.
Yeah.
The kind of workflow that would avoid that massaging you need to do.
Some of the interfacing between the like shader building logic and the render top can get a little weird. Like right now it produces this table that ends up going into like an export table that pushes settings onto the render the GLSL top.
Mm-hmm.
And for texture inputs, it is a little bit of a chaotic mess, where like if there was a way to have like a parameter on the GLSL thing that you can give it a list of multiple tops, and it would use those as inputs, that would make things like a lot easier. Because right now it like has to, anytime the like parameter table changes, it selectively connects out these different select tops and hooks up the right number of them, and it's a little bit like the set inputs method that was added recently helped a little bit with the logic there, but
I think there's a few nodes that do that.
Like composite top does that.
So that makes sense to add.
Yeah, that would definitely be helpful. I think that's it for all the kind of like infrastructure questions that I had.
Are you using cloning at all in your?
Selectively.
There
are in the development environment, like yes, for everything. So like in the inside of the source for this operator, there's an op definition that's being cloned out of somewhere. In the build process, it strips out all of it like detaches all of those clones, and in the compiled version, there will be a path in the clone setting, but enable cloning is switched off. And
turned off. Yeah, that's one way of turning it off.
There's a tool that you can use if you update to a new version of the toolkit. You can select a bunch of operators and click their update op, which will it'll reclone individual each of them with whatever the latest version is. So it was part of that. Avoiding dependence on external things and kind of being able to control when cloning happens, because an operator can't rely on the toolkit itself being present in the project.
That's right. That's a common thing where you update via just pulsing the enable cloning.
So it does mean that I think the size of the toolkit talks is probably inflated quite a bit because of that. Maybe. I don't know. I don't know much about how cloning works internally, but
probably a lot. Probably a lot larger. Are you? How do you find sending all your data around with DAT tables basically? And is there some limitation or inconvenience about doing things that way?
It works okay. I've kind of migrated, early on, in earlier versions of the toolkit, there were a lot of different columns in that. So pretty much every property of, the operators in there, so there would be the path to the code DAT, and the path to the parameters chop, and the path to the compiler macros DAT, and the path to and so on. So but then as part of this kind of replacing lots of DATs with smaller numbers of Python things, more of that has been moved into these structured objects, and then in the table that gets passed around, there's just a path to this DAT. There are some things that there are cases where an operator will modify properties of the definition that comes into it. Main use of that is for type resolution. So operators can have, there's 3 different coordinate types, possibly 4 in the near future, but 4D stuff is coming. But so a constant field, which just uses its parameter, it doesn't care about what kind of coordinates it's given, but it does have to take a type of coordinates. So it fills in, it says I can take any of these 3 types, and then in an operator that uses it, the operator that uses it might only deal with 2D and 3D, so it'll strip out the 1D coordinate option from that, and then as things go along, the types get winnowed down to, at the end of the renderer, everything there's 1 coordinate type, 1 return type, 1 context type for each thing. There's some amount of that modifying the definition of the tables as they go through the chain, but mostly they're just a reference to one of these structured DATs and a couple of tables.
Interesting.
Right,
but like you said, you're using, this is a JSON we're looking at right now, and you're pulling some stuff out of there using, I guess, some JSON code or dictionary evaluation or something. I know that there's some amount of cost to the JSON part, encoding and decoding, but it seems like it's not a big issue yet. But it's kind of, I tried for a while to I was kind of perhaps unduly afraid of that cost for a while, and so I was keeping everything in separate tables, but this seems to simplify a lot of things, and I haven't noticed too much performance cost. Okay.
And most of the path of that there's no changes on that while you're working with it. It changes if you connect and disconnect things, and sometimes if you change one of the menu parameters, but most of the time when a scene is just running, that path doesn't cook at all. It's only like the parameter chops that are changing.
Right. My last question. You have a bunch of camera models like fisheye and regular cameras, things like that. Have you ever thought? I've always wanted to ask a ray marching guy this question. So you're the one. Can you imagine rays actually curving as you're marching, so you can see around the backside of things?
That was a kind of experimental feature that I never fully launched. It's possible, and actually, this is one of the kind of pending areas of development is like refractive, like transparent material, glass, water, that sort of thing. So those do involve like changing the direction of the ray at certain points as it's going along. I haven't gotten the refraction thing working yet, but I used to have a kind of not well documented feature where you could have like a thing that would apply rotation at different points to the rays that they're moving through. It was like, I didn't find a particularly usable or good use for it, and so I pulled it out recently. But it might be worth adding back if I can get it to do something more useful. Yeah,
I was thinking more of an arc path. But anyway, that was my last question. I have a question for Isabel.
Wait, just we have to go back. Here we go. Okay, so we have three or 4 minutes left. Thanks, Tommy. That was so interesting and informative, and I'm sure this video is going to help a lot of people.
Sorry, we're missing your picture here, but
it should be. It looks like it's coming through on Teams, but.
I got a question for Isabel though. Can I see your T-shirt?
Dress for success today.
Ooh.
Yeah,
not quite the right banana, but.
That's a.
La Palma. We got a lot of bananas in La Palma. So. What do we have? I mean, upcoming things, Marcus. There's Roundtable Berlin. Roundtable.
Roundtable Berlin for anybody who is in Berlin. Yeah, coming up on Thursday at the Node Institute.
It's also streaming, right?
No, since they're they're in person again, they're not streaming. So
okay.
But anybody who's here, please come by. It would be nice to see everybody. Sorry if I haven't reached out to everybody or answered all contact emails. I'm getting there. But so Thursday at the Node Institute, I think it starts at 7. I'm not sure.
7 in Berlin time. So so work that out. Also, we're always looking for people to be on InSessions. So derivative.ca/InSession, and there's all the information there on how to reach us. And we invite you with open arms to please come and join us.
Talk a little bit about the project that you want to present, please, because there was a submission today, but I think the topic was la. And,
that doesn't work.
Does not apply in the rest of the field. So yes, a little bit of information would be nice. I guess that's it.
Yeah, thank you, Tommy.
Yeah, thanks, Tommy. It was great. It was great hanging out with you. It was great hanging out with you at UTech as well.
Yeah.
Good to see you there.
And do that when you're in LA next time.
Yeah, we'll be there in November, and probably going to organize a meetup. So we'll be in touch.
Great. Yeah.
Look at that beautiful stuff.
All right, guys. Time to say goodbye. Happy Equinox +1 day. And we'll see you again in a month or so.
Exactly. Yeah. Perfect. Have a good one, everybody.
All right.
See y'all.
Bye.